All right, our third video on beyond the basics of factoring. We're going to focus in this video on the formulas for the sum and the difference of cubes. So to start with, the sum of cubes formula looks like this: a cubed plus b cubed. It has two terms, just like the difference of two squares, but the two main differences are, of course, there's a sum instead of a difference, and the terms are perfect cubes, not perfect squares. The difference of cubes starts out the same way, it's just being subtracted, a cubed minus b cubed. And here's how these formulas factor. A cubed plus b cubed factors to, at first, just a plus b. Then a trinomial, a squared minus ab plus b squared. The difference of two cubes formula factors really similarly. To start off, it's got the same sign as the question, so a minus b, and then a squared, kind of like its partner formula. But instead of plus ab or minus ab, it's plus ab. So a squared plus ab, and then plus b squared. So what I want you to notice about these formulas is they both start off with a binomial, a and b, and the sign for the first two is the same sign as the question has. So if we have the sum of two cubes, the sum is in the first binomial. If we have the difference of two cubes, the difference is in the first binomial. Both trinomials start with an a squared, have a times b in the middle, and end with a b squared. The signs are the only part that's different. So the sign in the first binomial is the same as the question. The sign in the second trinomial is the opposite as the question. If the question has a plus, a cubed plus b cubed, it's an a squared minus ab. And then the final sign is always a positive, always positive for the plus b squared. Now these letters make an acronym that's used quite frequently, SOAP. So what I will be reminding you of when we're doing our examples is the SOAP formula for same sign, opposite sign, and always positive. Okay, here is how you use these formulas. So for our first example, let's factor something straightforward like x cubed plus 125. Okay, I want you to notice we have a sum. We have two terms. We have their sum, and these are both perfect cubes. I strongly recommend writing it in the form parentheses cubed plus parentheses cubed. It makes it easier to see who is A and who is B for your formula. So clearly for x cubed, x is being cubed. That would be our A. And for 125, that's 5 cubed. So that would be our B. And since it's a plus, we're going to be using the top formula. So the first part will be just a plus b, so x plus 5. Then we square whatever the first part was, so that will be x squared. Opposite sign, so subtract. And then a times b means we multiply these two numbers together. So x times 5 is 5x. And then always positive or always plus. The final number is 5 squared, or b squared, so that'll be a 25. And we're finished. Let's do another warm-up example. Ooh, that doesn't look good. There we go. Okay, let's factor 8y cubed minus 27. So I can tell I'm supposed to use one of these cubic formulas because, again, I have two terms. Unlike the difference of squares, this is a cube. They're perfect cubes, and I can write it in the form somebody cubed minus somebody else cubed. Okay, so who is being cubed or multiplied by itself 3 times to give us an 8? That's 2. And then certainly y cubed would be y cubed. Who's being multiplied to give us a 27? Well, that's a 3. So our a is 2y and our b is 3. Since it's subtraction, we'll plug it into this bottom formula down here. So a minus b would be 2y minus 3. Let me write the formula. A minus b, a squared plus ab plus b squared. So a squared, I'm going to square everything. I'm going to square the 2 and square the y, giving us 4y squared. Plus their product, a times b is 2y times 3. That would be a 6y. And then finally, 3 squared would give us a 9. So this is 2y times 3, and this is 3 squared. And this was 2y all squared. So there we have our answer, 2y minus 3 times 4y squared plus 6y plus 9. Okay, let's make these a little bit more college algebra level. I'm going to leave the formulas up for reference. So now let's factor x to the 15th plus 1,000. Okay, so we have to be able to write it in somebody cubed, in this case, plus somebody else cubed. I'm going to be a giant chicken and start with the easy one. What number do you multiply by itself 3 times in order to get a 1,000? That's a 10. Okay, remember back to what we were doing in the last section. When you raise something to another exponent, you multiply. So x to the what exponent, then multiplied by 3 makes 15. That'd be x to the 5. So I have a is x to the 5 and b is 10. And if my formula for the plus is a plus b, a squared minus ab plus b squared, then for this one I'm going to have x to the 5 plus 10. Okay, a little bit of work here. X to the 5th squared. Remember, multiply the exponents, so x to the 10 minus x to the 5 times 10 is 10x to the 5 plus 10 squared, which is 100. Cool. Okay, let's do another one. Let's do x to the 13th minus x to the 7th y to the 12th. Okay, problem here, I don't mind the 12 because it's divisible by 3s and these are cubic formulas. I do mind the 13 and the 7, but whenever we have a problem like that where we think it's not factorable by traditional methods that we've been practicing, probably there's a greatest common factor. So sure enough, there's 7 x's we can factor out, so let's do that. So x to the 7th, that leaves us with x to the 6th minus y to the 12th. So our common factor of x to the 7 will just stay in the front. And I want to rewrite this so I have somebody cubed minus, oh, I need more room there, something else cubed. Okay, so remember, when you're cubing something, you're multiplying by a 3. So to figure out how many x's do I cube to make 6, I'm going to go 6 divided by 3 is 2. 2 times 3 makes 6. And same with the y's. 12 divided by 3 is 4. 4 times 3 is 12. So I actually have x squared being cubed. That's our a. And y to the 4th being cubed. That's our b. And the formula we're using is the difference of cubes. So that is a minus b times a squared plus ab plus b squared. So for this a and b, oh, don't forget to the x to the 7th out front. A is x squared minus b is y to the 4. Okay, what is a squared? Well, a is x squared, so squaring x squared gives us x to the 4th. Multiplying the a and the b together gives us x squared y to the 4th. And then finally, squaring y to the 4 gives us y to the 8. So our answer still has the x to the 7 out front, times x squared minus y to the 4th, multiplied by the quantity x to the 4 plus x squared y to the 4 plus y to the 8. Okay, let's do a couple more examples before moving on. Okay, let's do x to the 7th minus 125 x to the negative 11th. Okay. Oh gosh, those exponents, negative exponents. Okay, clearly there's a GCF. Take out the smallest. Sorry. My dog is very upset that my husband is in the swimming pool. You can hear him barking in the background. If you take out the smallest number, that's x to the negative 11. So we're going to factor out x to the negative 11. And don't forget, when we do that, we subtract existing exponent minus exponent we're factoring out. So that would be x to the negative 11 times the quantity, okay, minus a negative 11 is plus x to the 18th. Minus 125, oh, and then the x to the 11s cancel. So I have x to the negative 11 times x to the 18th minus 125. So x to the negative 11 times something cubed minus something else cubed. So just like in the last one, to figure out who's being cubed, divide the exponent by 3. So 18 divided by 3 is 6. X to the 6th. Now, don't divide the numbers by 3, just the exponents. So what multiplied by itself 3 times gives you 125? That's 5. So our A is x to the 6th and our B is 5. So when we write the factoring, don't forget your x to the negative 11, but we're going to have difference of cubes here. A minus B times a squared plus ab plus b squared. So that's going to give us, let's see, a is x to the 6, b is 5. X to the 6 minus 5. Okay. X to the 6, when we square it, is x to the 12. When we multiply the a and the b together, x to the 6 times 5, we get 5x to the 6. And finally, when we square b, when we square 5, we get 25. So our answer is x to the negative 11 times x to the 6 minus 5 times the quantity x to the 12 plus 5x to the 6 plus 25. Okay, let's do a couple more. All right, let's factor m to the 8/3 plus 64 m to the negative 1/3. So hopefully we've got the idea. We're going to factor out the GCF for the m's, which is the smaller exponent, so m to the negative 1/3. And when we do that, existing exponent minus factored out exponent, so 8/3 minus a negative 1/3 leaves us with 9/3. Ooh, nice. 9/3 is just 3. And then plus 64, and the m to the negative 1/3 is factored out, so plus 64. So when we rewrite that as something cubed plus something else cubed, let's see, what cubed to be m cubed? Oh, that's easy, that's just m. And what number do you multiply by itself 3 times to make 64? Now be careful, 64 is a perfect square and a perfect cube, so that would be 4. 4 times 4 times 4 is 64. So for our formula, A is m and B is 4. So don't forget to write your greatest common factor in front when you're factoring out. Then we have, okay, this was the sum of 2 cubes, so a plus b times a squared minus ab plus b squared. So looking back at the work we did over here, a is m and b is 4. So a plus b is m plus 4. A squared is m squared minus, multiply them together, a times b, m times 4 is 4m. And finally, b squared is 4 squared, 16. So our answer is m to the negative 1/3 times the quantity m plus 4 times the quantity m squared plus 4m plus 16. A quick note on this second part, this trinomial that appears in both the sum of cubes and the difference of cubes. This m squared minus 4m plus 16, it never factors any further. And it sure looks like it could factor more, but it never is factorable. There are not any numbers that multiply to be 16 and add or subtract to be negative 4. So this a squared minus ab plus b squared, and the a squared plus ab plus b squared, it's always prime itself. It never factors further. Okay, let's do one last example. For our last example, let's factor 2x to the 4th plus 5x to the 3rd minus 16x minus 40. Okay, one very important thing I want you to notice about this is that there are 4 terms. And whenever there's 4 terms, we're going to use grouping. So we'll group the first pair and then we'll group the second pair. And in that first pair, looking for a greatest common factor, 2x to the 4 and 5x to the 3, the only common factor there is the x to the 3. And when we factor that out, we're left with a 2x and a plus 5. Very crucial but small step, bring down the sign that connects the first pair to the second pair. So we'll bring down the negative. And that's important because when we look at our 16x and our 40 and look for a common factor, 8 is the common factor there. That red negative we just factored out tells us we're not factoring out the number 8, we're factoring out negative 8. So negative 8 into negative 16x is positive 2x, and negative 8 into negative 40 is positive 5. That's crucially important because now we have a match. 2x plus 5 and 2x plus 5 match. So we can factor out the 2x plus 5, leaving us with an x cubed and a minus 8. Cool. Okay, we can keep going. We did a problem like this at the end of the previous video. This x cubed minus 8 is a difference of 2 cubes. So the 2x plus 5 just hangs out in front of the problem like the GCFs did before. And somebody cubed minus somebody else cubed for our formula in the x cubed minus 8. Okay, clearly, who is being cubed to give us an x cubed? Well, that's x, so a is x. Who is being cubed to make 8? That's 2, so b is 2. So when we go to write our next step, write in the 2x plus 5 in the front. We don't want to forget that. And then leave room for our formula a minus b, a squared plus ab plus b squared. So let's see, a minus b is x minus 2. A squared is x squared plus a times b means multiply, so x times 2 is 2x. And then finally, b squared means 2 squared, so plus 4. So our answer is 2x plus 5 times the quantity x minus 2 times the quantity x squared plus 2x plus 4. And just as a quick reminder, even though x squared plus 2x plus 4 looks tempting, like it might factor, it never does. There are not a pair of numbers that multiplies to be 4. There is not a pair of numbers that multiplies to be 4 and adds or subtracts to be 2. So we're finished.